Okay, so this video is going to explain the thought process of how I did it and try to help you guys with it. I'm not going to explain everything. You should, that's me to say you should know this. Um, you should learn it if you don't know it. Yeah, that's better. So a advice is to find the homogeneous equation first before finding the particular solution. As you can see here, I found my homogeneous, the roots basically. And basically we have a real number and we have an imaginary number here, represented by this roots. So the equation would be this. Plug it back in here and we have our homogeneous equation. You're probably wondering, oh, why do we find the homogeneous equation first? So the reason why is to avoid duplication within the particular solution. And if you don't find, like, if you missed, oh shoot, there is a duplication, but you missed it, your whole thing will be wrong. So let's do an example. Right hand side, I would assume you would know this already, right? So we have x squared plus bx plus c cosine x plus dx squared plus ex plus f sine x. And this is wrong, basically, right? If you don't know why, this has the same thing, right? C cosine x, this has the same coefficient as this part right here. And we have f sine x, and this has the same coefficient as this one here. So you see there's a duplication within a particular and the homogeneous equation. So that's a no-no. We say this is wrong with the mad face. Oh, I spent so much time doing this. But don't worry, you'll be happy. All you have to do is multiply the independent variable by this, right? All this, right? Your particular solution you found. And boom, we multiplied our independent. Isn't that easy? So what we do after that, we check, is there any more, or are there any more duplications? And as you can see, there is not. So we are happy, everyone's happy, and we would go along our day. So what we would do first is find our prime, right? So I'm going to explain what or how I did the prime. All I'm going to say is I just did a lot of product rules. A lot. So basically, I found prime and I found double prime. You can see what I did here. You can copy what I did here. I'm not too sure if it's correct. This is my thought process. So we have found double prime. We have our prime here, right? And we have our just y. Our y sub p is our particular solution. And what we want to do is plug this back into here, right? So that's what I did here. You can pause the video, but I'll explain what I did. So this is our double prime, y double prime, and this is our, this is our just y, our particular solution, because just y with no derivatives. So I did is basically cancel all the similar terms out, right? So we have ax cubed cosine x, the negative sign here, and that cancels out. Negative bx squared cosine x, that cancels out, and so on. You get the rules. I color coded it for you guys. And now I just have the remaining stuff here. And what you want to do is match the coefficients. I don't know if I'm using coefficients correctly, but I'll do an example. So let's do what has x cosine x. Let's look through here. Boom, x cosine x. We have, what's x sine x? What has x sine x also? Oh, this one as well. Oh, what has just sine x? Just sine x. Where is it? Oh, right here. As you can see, we just find each other like the X, like a pirate. I don't know how you draw a pirate with the legs, with the eye patch. I don't know. So basically, we group those together, and I color coded for you guys so it'll be easier or visually pleasing to look at. So you have 6A and we have 4E, right? 6A, 4E, and we have this part here, right? And so on and so on. I don't know how to use the wording, so forth. Um, yeah, until we have this, right? And we'll make that equal to our right-hand side, which is x squared cosine x. And what we would see is x squared cosine x. Which one has x squared cosine x? Is it this one? Nope. Is it this one? Nope. This one? No. This one? Nope. This? No. Now, you can see we do have the same thing on the right hand side. So what we would find is that we would make it equal to each other, right? We have this 60 x, is it 60? Yeah, x cosine x, right, is equals to x squared cosine x. This has the same coefficients, so this would just be 1, right? We just cross this out, this one out, and this one out, right? So we have 60 equals 1, and doing algebra right here, we have d equals 1/6. Next step is to find what else has d in the equation. Which one has d? But this one has d, right? So we could plug in 1/6 into d. And you're probably wondering, why do we have it equal 0? The reason why we have it equal 0 is because there's nothing on the right-hand side that has x sine x, right? There's nothing on the right-hand side that has x sine x. Nothing. So just basically you could think of it as 0 times x sine x. And you can think of this right here. Oh, let's keep going. So we plug it back in. We have negative 4b equals negative 1, b equals negative 1/4. And we see, what has b as well? Oh, ding, 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 this has b. So we plug in b into this equation. And the reason why this equals 0, like again, we have nothing on the right-hand side that has a coefficient of cosine x, right? So basically, we plug in b into this equation. We have f equals negative 1/4. And now we see which also has f. No, 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 nothing else has f, right? So we could basically just say everything else equals 0, right? And what we do with the f, b, and d, we will plug it back into our particular solution. So right here, I plug in 1/6 here, we plug in b here, and we plug in f here to get this. And overall, at the end, I don't know if my answer is correct, but this would be my particular solution. I hope this helps.